Hey, Algebra 2, this is section 5.9, the quadratic formula and the discriminant. So earlier we talked about the quadratic formula. We went through and did the proof in class. I'm not going to do that again. But we know the quadratic formula is going to occur anytime we have a quadratic equation in standard form, ax squared plus bx plus c, and it's set equal to 0. So now I can find the solutions, what x will be to make this a true statement. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And later on we'll talk about the importance of what's under the radical, and that's going to be the discriminant. So I got a few examples that we'll do, and let's take a look at these and see how we do. So the first example gives me a quadratic equation set equal to 0, and one of the things we have to look at is the standard form ax squared plus bx plus c equals 0. So I know a is going to be equal to 1. You don't need to do this every single time, but b equals 3, especially early on, it's good to do. And c equals negative 5. So we just said the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Apologize for that. So now let's substitute in what we know. B is 3, so negative b, which just means the opposite of b, is going to be negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c. C is negative 5, all over 2a. 2 times 1 is just 2. Let's simplify. 4 times 5 is going to be 20, and it's negative times a negative, so it's going to be positive. So we are left with negative 3 plus or minus the square root of 29 all over 2. Okay, and if they want the exact value, we'd leave it at this. And just a reminder, we could find an approximation of this by putting it into our calculator, but a reminder, this is two solutions. 3 plus square root of 29 over 2, and negative 3 minus square root of 29 all over 2. And I think if you do it out on the calculator, you're going to get 1.19 and negative 4.19. But most times we're going to want this as an exact value. Okay, let's go to another example. All right, example 2. This time our quadratic equation is not set equal to 0, so we have to go through and set it equal to 0. So we're going to add 9 to both sides. Again, whatever I do to one side, I have to do to the other. Negative 9 plus 9 is going to equal 0. So I have x squared minus 6x plus 9. Now it's a quadratic equation set equal to 0. I can use the quadratic formula. I'm not going to write out the formula again. We know x equals negative b. So that's going to be positive 6. That's the opposite of b. Plus or minus the square root of b squared. Negative 6 times negative 6 is 36. Minus 4 times a, which is 1, times c, which is now 9. All over 2a. 2 times 1 is 2. 4 times 9 is 36. So we're going to get 6 plus or minus the square root of 36 minus 36, which we see is going to be 0. So 6 plus or minus the square root of 0 over 2. Square root of 0 is 0. Plus or minus 0 is just 0. So 6 over 2 is 3. So we get one solution. Okay? And we'll find out what that means in a little bit. All right, let's go on to the third example. Okay, now this is a quadratic equation set equal to 0, so I can use the quadratic formula to solve this. X equals negative b plus or minus the square root of b squared, so it's going to be 4, minus 4ac, that's 4 times 1 times c is 2, all over 2 times a, which, again, a is understood to be 1. Let's simplify this. 4 times 2 is 8. So we get negative 2 plus or minus the square root of 4 minus 8 is going to be negative 4 all over 2. I know the square root of negative 4 is going to be 2i. Remember, I equals the square root of negative 1. Okay, and that was all over 2. And now I can factor out of 2, and I'm left with negative 1 plus or minus I over 1. So again, that gives me two solutions. And they're both going to be imaginary solutions. Let me just write these out separately. Negative 1 plus I, negative 1 minus I. And one of the things we talked about before was anytime you have one imaginary solution, you also have to have its complex conjugate as another solution. So we looked at if there were going to be 4 solutions and 2 of them are real, then you'd have to have 2 imaginary solutions. You can never have an odd number of imaginary solutions. It's either going to be 0, 2, or 4. Okay, now so we've had an imaginary solution, we've had a solution of 0, and we've had 2 real solutions. Let's look at that other component, which is the discriminant. So let's put this color here. Discriminant of a quadratic equation. This is going to determine the number and type of solutions. So whenever the discriminant, which is the part of the quadratic formula under the radical, whenever b squared minus 4ac is greater than 0, what does that mean? It's positive. That means there's going to be 2 real solutions. But what does that look like on a graph? That looks like this. If the parabola is opening up, that means the vertex is below the x-axis and it crosses the x-axis at 2 different points. And this always happens whenever the discriminant is positive. When you think about it, when you get a square root of a positive number, you're going to get 2 possible roots, and the plus or minus, the square root of b squared minus 4ac, so it's going to be plus or minus positive value. You're going to get 2 answers. And if for some reason the parabola is opening down, the parabola would look like this. So again, we're going to get 2 roots with a quadratic equation is going to equal 0. If the discriminant equals 0, so you can get plus or minus 0, like our example 2, we're only going to get 1 solution. So what does this look like on a graph? This looks like the vertex is on the x-axis, so there's only 1 value of the parabola that equals 0. If the parabola opens down, it will look like this. Once again, the vertex is on the x-axis, so there's only 1 value of the quadratic equation that's set equal to 0. And again, that's the vertex. And now what does this look like if the discriminant is less than 0, which what does that mean? It's negative. I'm going to have 0 real solutions, and more specifically, I'm going to have 2 imaginary solutions. So here's my vertex, and this parabola opens up. It's never going to cross the x-axis. Or I could have a parabola with the vertex below the x-axis with the parabola opening down. Again, it'll never cross the x-axis. Therefore, there's going to be no real zeros. I'll have 2 imaginary solutions, but no real zeros. Okay, last page, one example. Let's do this for all 3 possible scenarios. So find the discriminant and give the number and type of solutions. So how many are there and what type? It's either real or imaginary. So b squared minus 4ac is the part of the quadratic formula under the radical, and that's what we use. That's all we have to use. So b is the negative 6. So I'm going to go negative 6 squared minus 4 times 1 times 8. That's my AC. Negative 6 squared, again, make sure you put the negative in there, or just know that any number squared is going to be positive. 36 minus 48. So we know when we combine these, we're going to get negative 12. And let's write that down. So oh, I'm sorry. Catching a mistake. This is not going to be 48. Let's try that again. 4 times 8 is 32. I don't know why I had a different answer there. 36 minus 32. All right, try that again. 4 times 8 is 32. 36 minus 32 is positive 4. So this is the number. Excuse me, this is our discriminant, which means I'm going to get 2 real solutions. Okay, so that's what they mean by number. 2 real solutions. So my discriminant is positive. B squared minus 4AC is greater than 0. So I get 2 real solutions. All right, let's try the next one. Again, it's x squared minus 6x plus 9. So now almost everything's the same. B is negative 6. We're going to square it and get 36. See if I can actually multiply these this time. 4AC, A is still 1. C is 9. 4 times 9 is 36. So I get a discriminant of 0. Well, we know anytime the discriminant is equal to 0, we are going to get 1 real solution. And that was the example when the vertex was on the x-axis. Okay, and now the last one. And again, notice all we changed was this one was 8, this one was 9, and now this one's 10. So b squared, that's negative 6 squared, which is going to be 36, minus 4 times a is 1, times c is 10. 36 minus 40 is negative 4. So I have the discriminant that is less than 0, which means it's a negative number. So I am going to get 2 imaginary solutions. Okay, we originally talked about it as both 0 real solutions and 2 imaginary solutions, but now we can just talk about it as being 2 imaginary solutions. Okay, last slide. This just introduces some of the vertical motion models. And so something is being dropped or falling. And here's what these stand for in the formulas. So if it's just dropping, it's h equals negative 16 t squared plus h naught. That's what that 0 stands for. The original h is the height of the object, again, at any given time. H naught is our initial height. Both of those are in feet. T is the time in motion, and that's in seconds. For those of you that have taken physics, the negative 16 has to do with half of the speed of gravity in feet per second, which is 32 feet per second. So you might have seen negative 1/2 gt squared. So g is 32 feet per second. So half of that is 16. Okay, and if I either launch the object straight up in the air or we throw it down, whatever it might be, this is now going to be the height at any given time equals negative 16 t squared plus v naught. That stands for initial velocity, and that's in feet per second. So v naught times t plus the initial height. So the difference between the two, if you're dropping it, if you just drop it or let it go, the initial velocity is 0. 0 times the time is 0. So you could use this for both scenarios, just knowing that, again, if it's dropping, there's no initial velocity. So if you throw it, then obviously there's initial velocity, and you're going to need to have that component in. So there's 2 formulas there. This one would work for both of them, knowing that you're either going to have initial velocity, again, initial vertical velocity, or if you're dropping, the initial vertical velocity is 0, and that would cancel it out, and it gives you the same thing we have up above. So good luck, and this is section 5.9, which is working with the quadratic formula and the discriminant.